May 10, 2024. Under rare clear skies, Mount Rainier erupted in crimson light, captured in viral footage that left thousands questioning. Was this mountain on fire, or was something even stranger happening in the night? As emergency calls surged and panic spread, the true cause remained hidden. What could turn a glacier blood red without warning? A single frame, time-stamped 9:47 p.m. Pacific Time, sweeps across the screen. The sky above Mount Rainier is velvet black, broken by a band of deep red that seems to set the summit ablaze. In that moment, the mountain's glaciers, usually blue-white under starlight, pulse with a color no one expects to see after sunset. The air is clear, remarkably so for western Washington in May, when clouds and drizzle are almost a nightly certainty. Barometric readings from nearby weather stations confirm what the footage shows: a rare cloudless window, with visibility stretching from the foothills to the peak. The footage, captured and uploaded at Sean Scapton's TV, spreads within minutes. No one can look away. Comments pile up beneath the video, each one echoing the same disbelief. Is Rainier on fire? Has anyone ever seen this before? The photographer's voice, caught in the background, is breathless, half in awe, half in confusion. He checks his camera's settings, then the horizon, searching for any sign of smoke or eruption. Instead, the only thing moving is the slow drift of red light, painting the snowfields as if the mountain itself is glowing from within. On this night, every detail, the open sky, the stillness, the perfect alignment of mountain and aurora, feels impossible. For a few minutes, the ordinary rules of night and mountain are suspended. The timestamp remains stamped on the footage, a silent witness to the exact second when Mount Rainier became the center of a mystery. By 10 p.m., the first wave of uncertainty had already swept through towns ringing Mount Rainier. Phones lit up in police stations and fire halls from Enumclaw to Eatonville. Residents stared out kitchen windows or pulled over on dark highways, trying to make sense of the red halo shimmering above the mountain. Some called friends and family to ask if they saw it too. Others dialed non-emergency lines, their voices hushed and urgent, describing a glow that looked too much like fire for comfort. Rumors began to ripple across neighborhood Facebook groups and local Reddit threads. Was Rainier erupting? Was there a wildfire on the upper slopes? In the span of 3 hours, dispatchers logged a steady trickle of inquiries, enough to keep lines busy, though nowhere near the chaos of a real disaster. Most callers wanted reassurance. They asked if they should pack a bag, or if evacuation was coming. A few demanded answers, convinced the authorities were hiding something. On social media, speculation outpaced facts. Viral posts paired dramatic images with captions like, "Rainier is burning," and "Red sky over Washington, what does it mean?" The sense of wonder from earlier in the night gave way to a sharper collective anxiety. For many, the line between awe and fear was paper thin. In the absence of official answers, every new photo or rumor only added to the confusion. The mountain, silent and unchanged, became the center of a spreading unease that demanded explanation. Solar storms begin far from Mount Rainier in the restless atmosphere of the sun. On May 10, 2024, a series of coronal mass ejections, massive eruptions of charged particles, blasted from the solar surface. These were not ordinary bursts. Space weather scientists tracked a phenomenon called a cannibal CME, a faster ejection that overtook and merged with earlier, slower ones, creating a single high-energy front racing toward Earth. By 2300 UTC, satellites confirmed the arrival. Solar wind speeds soared past 800 kilometers per second, and the interplanetary magnetic field snapped southward, two ingredients for a geomagnetic storm of the highest order. The Space Weather Prediction Center at NOAA issued a G5 alert, the top of the scale. Only a handful of storms in living memory have reached this level. As the storm struck, billions of charged particles collided with Earth's upper atmosphere. These particles, funneled by the planet's magnetic field, slammed into oxygen and nitrogen high above the surface. The collisions released energy as light. In most auroras, green dominates. But G5 storms carry so much energy that the red lines, especially at 630 nanometers and 656 nanometers, ignite across the sky. This is hydrogen alpha light, the deep crimson seen only in the most extreme events. Forecasters at NOAA described the May 2024 event as exceptional, with auroral emissions strong enough to be visible deep into the continental United States. The energy did not come from the mountain or the ground. It arrived from space, riding a wave of solar wind that transformed the night sky above Washington. The red glow over Rainier was not a warning from the volcano, but a sign of the sun's reach painted in rare colors across the atmosphere. Snow and ice on Mount Rainier act like natural mirrors, amplifying every hint of color that touches them. On nights like May 10th, when auroral light reaches far south, the mountain's glaciers become a canvas for the sky's rarest shades. Fresh snow has an albedo between 0.8 and 0.95, meaning it reflects up to 95% of the light it receives. Under intense red auroral emission, that reflectivity turns the upper slopes into a beacon, sending the crimson glow back toward anyone watching from the lowlands. The effect is strongest when the geometry lines up. Auroral rays strike north-facing glaciers, and the observer's line of sight matches the angle of backscatter. This is known in optics as the bidirectional reflectance distribution function, called BRDF. When conditions are right, the snowfield doesn't just reflect light, it seems to radiate it, creating the illusion that the mountain itself is glowing from within. Cameras only intensify this illusion. Modern sensors are especially sensitive to red wavelengths, particularly around 656 nanometers, the signature of hydrogen alpha light. Most night sky photographers shoot with high ISO settings between 1600 and 6400 and exposures of 10 to 30 seconds. These settings allow the sensor to gather every stray photon, building up a saturated image that goes beyond what the naked eye can perceive. Some use H-alpha filters, which block all but the narrow band of deep red, making the effect even more dramatic. The result is viral images that look almost supernatural, with glaciers glowing scarlet against the dark. But this is physics, not fantasy. The mountain's apparent inner fire is a trick of light, surface, and sensor, a perfect storm of optics that can easily fool even the most seasoned observers into thinking something is happening inside the volcano itself. USGS volcanologists at the Cascades Volcano Observatory watched their screens as the red glow swept over Mount Rainier. Seismic monitors, tuned to pick up the smallest tremors, showed nothing out of the ordinary. No earthquake swarms, no bursts of high-frequency shaking. Baseline seismicity held steady, mirroring the quiet pattern that has persisted for years. Gas sensors spread across the upper slopes continued to log typical levels of carbon dioxide and sulfur dioxide. There were no spikes, no sudden plumes, the kind of signals that would hint at magma moving beneath the surface. GPS and tilt meters, designed to catch even millimeter-scale swelling of the mountain, recorded no uplift or deformation. In short, every system pointed to normalcy. This is the daily reality for Rainier, a volcano under constant surveillance, with data flowing in around the clock. The contrast with Mount St. Helens in 1980 could not be starker. Back then, weeks of escalating earthquakes and visible ground swelling left no doubt that something was brewing. On this night, Rainier's instruments told a different story, one of deep, undisturbed sleep. The red glow in the sky was a spectacle, but the mountain itself remained unchanged, its silence confirmed by the numbers. For the people whose ancestors have called this mountain home, the site of Tahoma, sometimes called Tacobet, bathed in red carries a different weight. The name Tahoma itself speaks to the mountain's enduring presence in Coast Salish traditions, where stories pass from generation to generation, honoring both power and mystery. Some oral histories tell of times when the mountain glowed or seemed to burn, symbols woven into the cycles of change and renewal. While there are no public statements from tribal leaders specifically about this aurora, the mountain's place in their world is not measured only by science or spectacle, but by respect and relationship. The photographer who captured this night's images stands quietly at the edge of the snow, camera in hand, voice barely above a whisper. AWE replaces fear. In that moment, the line between explanation and reverence blurs. The red sky over Tahoma is not just an atmospheric event or a viral photo. For some, it is a reminder that the mountain is alive in ways that cannot be measured, its stories carried forward in every unexpected glow. Space weather is no longer just a distant spectacle. It now directly shapes headlines, fears, and what we see above our own towns. As solar cycles intensify, moments like this remind us the boundaries between cosmic events and daily life are thinner than we think. The sky is watching too.